Our space operations oversees the space shuttle and space station buildings. Yeah.
All right, we'll keep this kind of informal, and thank you all for coming out to see this and being part of this great team. Hopefully you get a chance to listen to some of the folks and talk to some of the folks and get a chance to see what passion they really feel in their hearts. You know, when you get to hear Wheels talk about the launch countdown and all the calls that are going to occur, those are nice academic things, but then when you think about the real humans and the folks that are really involved with all that and all the dedication and the effort and the time that's gone in to make all this work and look as easy as it is, I can tell you it is not easy, and it really works the way it works just because of the dedication of the teams and the folks that work down here. And there's a real passion and a real spirit that really drives us all to seek the absolute best in what we're doing. So again, thank you for coming down. Thank you for participating in this activity. We'll see what the weather does. You know, our job in the Mission Control and the Launch Control Center is make sure we get the vehicle ready to go fly, and then we'll let the weather be whatever the weather is. So we'll see how that goes the next couple days. The tanking team will come in tonight. They'll take a look at one last chance at the weather, see what they think tonight. They'll make a call on whether we go tank the vehicle or not. Probably more than likely going to go ahead and tank the vehicle just to see what happens, because all we need is no rain showers within 20 nautical miles of the launch complex. So we might get a chance to get that, we don't know, but we'll go ahead and see. But they'll make the final call this early tomorrow morning. So with that, I think I'll just be quiet, maybe see if you guys got any questions or anything you want to know. You can ask anything that you'd like to ask, and I'll try to answer whatever I can. Again, thanks for coming. So I think
we've got the first question on the left.
When they're decommissioning these shuttles, what do you take off exactly and what stays on when it's going to the museum?
Again, the museums want to keep the shuttles in almost as good a condition as they were when they were flying. So they really don't want us to take hardly anything off. There's some lines and plumbing that have toxic chemicals in them. Our rocket propellants, nitrogen tetroxide and monomethylhydrazine, are both corrosives. They're also carcinogenic, so we have to remove those components. So we'll pull those off, we'll clean those up, we'll remove some of those lines. We also have some areas in the vehicles that we've not had a chance to go look at while they've been flying. There's some actuators that move the ailerons and move the rudder speed brakes and move some components around. We've not had a chance to go look at those components since the vehicles were manufactured. So we'd like to, from an engineering standpoint, get a chance to go in and look and see if they're as pristine as we think they are, or if there's something there we might learn from. So we'll pull a couple of those components out kind of on a non-interference basis with museums. But museums want us to give us the vehicles in as good a configuration, much like they're ready to go fly, as we possibly can. So that's the way we're heading for the vehicle configurations.
Your next question's on your right over here.
Okay.
Good morning, Kara DeFrias. I would love to hear you describe your proudest moment.
Wow, my proudest moment. I will tell you, my proudest moment is when I see the Space Shuttle team actually rise to the occasion and work a problem or a challenge. You know, several flights back, we had an event out at the launch pad where we had a hail strike out at the pad, and there were 6,000 dings on the external tank on the foam structure. And I remember going out and looking at the tank. We rolled it back to the vertical assembly building where we do our processing. I remember going out and looking at the tank, and I'm thinking to myself, there's no way we're going to be able to repair this tank. And then I saw the team tell me, no, I think we can repair this tank. And then to see this team pull together, and it wasn't just the workers here in Florida. You know, the tanks are manufactured in New Orleans, so they had to figure out a way to work together. It turns out we keep track of the tile on the bottom of the orbiter. There's 30,000 tile or so on the bottom of the orbiter, so we had a program to do that. So we loaded into that program all the little dings or imperfections on the tank. We figured out a way electronically for the teams in New Orleans to send engineering paper here to Florida. The teams here would actually make the repair, take pictures, send the data back to New Orleans, and they would approve the repair. So what I got to witness was an unbelievable effort by this team with really no instruction from us, no guidance from us, just the basic we need to get this vehicle back in flight configuration, and they rose to the occasion to get that tank ready to go fly in a remarkable amount of time. It took us several months to do all the repairs. That tank flew, we had no foam loss, and it was just outstanding. So I think, if I think back, when I see what this team can accomplish, if you can construct a challenge for them in simple terms, there is no question what this shuttle team can do to really achieve the impossible and then make it look easy. Questions? Any more questions?
I'm actually just interested a little bit on the comment you made about the actuators. And I was just wondering, is there some data that you've seen that has sparked that motivation to go check on those? Or is it a lack of data? Or is that something that a supplier is looking for? Or
I use the term with the team, stay hungry. And by that, I mean stay curious. So we really don't have any indication that there's anything going on there. But we know from aircraft world that actuators typically don't stay in service for that long. So then the curiosity side of me says, is there something that we're doing that's better or worse than aircraft industry? So the curiosity side says, for the next spacecraft, let's go take a look and see what we can find out. So again, I think one way you keep safe and the way you keep flying safely is you keep that hunger where you're kind of inquisitive. And even though the data doesn't say anything's wrong and everything looks okay, is this something we ought to go look at, or can we get some more information? You know, we're even doing it on this flight. We've got permission now to keep the transmitter on the camera that's on the external tank on all the way through tank reentry. So we turn it off when we go over England because the radio transmits at a frequency that's not compatible with European radios on the ground, but we got special permission for them to leave this little 15-watt transmitter on. And the idea is we're going to activate some ground sites along the way so you can actually see potentially what the tank looks like as it goes below apogee and starts re-entering and breaking up. And again, there's no reason logically to go do this, but we think this is really good data for us to go look at how a large structure like the tank actually breaks up. We've done radar images from the ground, but we've never had the ability to actually use a camera on the tank to capture those images. We may not get any images depending on how things work, but it's worth a try, no harm, no foul. So my message is to the teams is stay curious, keep looking, keep thinking about what might be there, and that can prevent the next problem that's coming around the corner if you're looking for this kind of thing.
Okay, we've got a question over on your left here.
All right?
Yeah, I was just kind of curious when you guys pulled that main fuel valve out. Did you take it to the shop and find anything wrong with it, or?
Yep, we pulled the main fuel valve out and we found a little piece of contamination in there. It was 10 thousandths of an inch by 14 thousandths of an inch. It was a little piece of material in there. It turns out that that's not a concern for us. It's a particle that's allowed in the engine system, that's small, but it just happened to sit right on the right spot. So it's just like a washer kind of in maybe your sink where there's a compression fitting. It's Teflon in this case, and it's a ball valve, and where that ball rotates, it sits on that little Teflon surface, and you can see where it rubbed and compressed the Teflon, and right in the middle of that little piece sat this little tiny piece of debris. And it turns out at normal temperatures, it doesn't leak, but when you chill the system down to the temperatures it sees when the hydrogen's flowing through it, it was enough to cause a leak to trip the sensor. So we're pretty confident we found it. It's not a big deal to us. We changed it out. We got a new valve in. They've done the tests, and we should be okay with that problem.
We have time for 2 more questions. Over here.
Want that back?
Hi.
Thank you.
What would you say are some of the biggest things that you have learned from the spatial program as far as how we go about flying missions, and what the goal of human space flight is, and how we deal with risk and stuff like that?
Okay, you know, I think what we really learned